So now we're going to talk about how to graph x and y on an xy axis. So we're going to take our values from our unit circle and look at what does the graph of y equals sine x look like. And we've already seen a little preview of this when we solved for theta using our graphing calculator. We saw the shape of the sine and cosine and tangent curves a little bit then. All right, so if we're going to graph something and we have no clue about transformations or shapes or anything, let's make a chart. So in this section, the trig functions have the angle as the input and the trig value is the output. So that means that when I'm making a chart, let's make a chart up here. When we say y equals sine x, x is going to be an angle. Let's start at 0. And then we'll want to figure out what's the sine of x and what's the cosine of x. The reason I put them in that order is just because we're graphing sine first. So at 0, sine is 0, cosine is 1. At pi over 6, sine is 1/2, which is pretty easy to graph, but cosines is not as easy to graph, radical 3 over 2. So, and we could kind of go through there and say, well, we could plot pi over 4, we could plot pi over 3, but let's go ahead and skip to the nice integer values. So let's plug in pi over 2. Sine is 1 and cosine 0. And then we can plug in pi. Sine is 0, cosine's -1. And then 3 pi over 2. Oops, 3 pi over 2. And sine is -1, cosine is 0. And finally, if we finish up at 2 pi, we get back to 0 for sine and 1 for cosine. So we're getting one period of sine because look at what we cycle through: 0, 1, 0, -1, back to 0. And if we went a second time around the circle, if I said, all right, after 2 pi is 5 pi over 2, and then if I kept going, right, 6 pi over 2, 7 pi over 2, 8 pi over 2, I would keep getting those same 4 points. So let's graph the sine curve, the nice points. That was 0, 0. And then look at where this is labeled already. So we don't have a spot for pi over 6. This is pi over 2. This would be pi over 4, half of pi over 2. But at pi over 2, we hit 1. At pi, the coordinate's 0. At 3 pi over 2, -1. And at 2 pi, 0. Now, if we did plot all of the angles that are between 0 and pi over 2, so think about all the spaghetti graphs that are out in the hallway. If we plotted the y coordinate here, this height of 1/2 at pi over 6, we would hit 1/2 somewhere. And we would also hit this distance of radical 2 over 2, whatever that calculates out to, right? At pi over 4. And then we would get something close to 1, but not quite if we did pi over 3. So if you can imagine, that would create this little curve. And that curve would continue itself. You're going to get to your peak, and then the values get smaller again. So the next point might be here and then here. So the reason we only plot the integer points is because we don't really need to know where radical 3 over 2 falls. We just know this is a smooth curve. So same thing here. So when I'm graphing sine and cosine, I really only plot the extremes, the max, min, whatever. Now, this graph will continue on forever, as periodic functions do, so put an arrow on that end. And what if we wanted to go in the negative direction? So what about if we started at, let's go negative. What about negative pi over 2? Well, negative pi over 2, you're down at the bottom of the circle, so sine is -1, cosine is 0. Negative pi, you're still at pi, sine is 0, cosine's -1. Negative 3 pi over 2, now you're at the top of the circle. Sine is 1 and cosine 0. And negative 2 pi is a full circle, back to 0, back to 1. Let's plot those points. Negative pi over 2 brings us down to -1 for sine. Negative pi is 0. Negative 3 pi over 2 is up to 1. Negative 2 pi is 0. Now, maybe I didn't need the table for that because remember, this is a periodic function. So if I have one period, I have enough to say, oh, I can just copy that same pattern for this side too. So it's got the same shape. We'll see how it goes from left to right. 0, 1, 0, negative 1, 0. 1, 0, negative 1, 0. 1, 0, negative 1, 0 is how it's going to keep going. Okay, so what are the global max and min values for the sine graph? The global max, what's the highest point? 1. And the global min, which is absolute min, absolute max, is negative 1. What's the period of the sine graph? So we went from 2 pi to 0, or 0 to negative 2 pi. If you subtract that, the rightmost point from the leftmost point, you get a period of 2 pi. Is y equals sine x even or odd? So remember, even or odd, even is y-axis symmetry, and odd is origin symmetry. All right, so even or odd, this looks like origin symmetry to me, right? We've got this point up here, x, y. We've got negative x, negative y down here. So sine is an odd function. That means that f of negative x should equal negative f of x. The point that's at negative pi over 2 should be the negative version, negative, times the point that's at pi over 2. Or the point that's at negative 3 pi over 2, multiply that by negative 1, you get the point at 3 pi over 2. Between negative 2 pi and 2 pi, on what intervals is y equals sine x concave down? So concave down looks like a frown. It looks like negative 2 pi to negative pi. And then concave up, and then concave down again, 0 to pi, and then concave up again. I'm using parentheses because remember, at these changeover points, the graph, that's a point of inflection. The graph is neither concave up nor concave down at that point. Okay, what about the cosine graph? Well, we already have the coordinates generated, so let's go ahead and plot these. All right, so the cosine graph at 0, now I'm not going to scroll up and down for these, so you can see it all on your paper, but at 0, we plot 1. So 0, 1. At pi over 2, cosine is 0. The cosine of pi is negative 1. 3 pi over 2 is 0, and 2 pi was 1. For the same reason that I'm not plotting pi over 6, pi over 4, pi over 3, I'm not going to do that here, but those values at pi over 6, we're saying how far across is the graph from the y-axis. So it's pretty far away from the y-axis, then it gets closer you get to 0, or to pi over 2. So anyway, this is going to be a gradual curve as well. Make sure it doesn't look like an absolute value graph. Now be careful when you draw the rest of the graph. It's going to go down after this, so put your arrow down. And then if I do the negative angles, I could look at that table, or I could just copy the pattern, right? The pattern is just, so start on the far left. At negative 2 pi, you're starting at 1. At negative 3 pi over 2, you hit 0. And then negative 1, and then 0, and then back up at 1. We just got done talking about periodic functions in the last set of notes, and so this is periodic. We're using that fact here. On the cosine graph, what are the global max and min values? Well, the max is 1, and the min is negative 1. So just like sine, they have that in common. And the period is the same too. The graph starts and stops at 1, at 0 and 2 pi. It goes through its entire cycle in that distance. So again, the period is equal to 2 pi. Is y equals cosine x even or odd? So cosine x has y-axis symmetry, so it's an even function. And that means that f of negative x should be the exact same as f of x. So the point at negative pi over 2 should be exactly the same as the point at pi over 2. Or the point at negative pi should be exactly the same as the point at pi. And between this interval, on one interval is the graph of y equals cosine x, concave down. Again, looks like a frown. So this one, there's these little half sections, like we're from negative 2 pi to negative 3 pi over 2, which is a point of inflection, because then it changes concave up. And then negative pi over 2 to pi over 2. And the last section is on the end there, 3 pi over 2 to 2 pi. So what if we have the function y equals sine of 2x? This is a horizontal dilation by what factors? We did this way back in the first quarter. You have a 2 on the x value. So remember what that means. That means that we should take every original xy and transform it so that the x values get divided by 2, and we'll leave the y values alone. So what is this horizontal dilation? It's by a factor of 1/2. And think about what that's doing. If you divide every x value by 2, if you divide every x value by 2, or if you multiply x by 1/2, that's a horizontal shrink. We don't usually have to specify that for our AP test, but we do have to know the factor. So think about the original graph. Let's just sketch this. The original graph, let's mark off where 2 pi is. Halfway would be pi. Half of that's pi over 2, 3 pi over 2. The original sine graph started at 0 and then went up to 1, 0, -1, 0. This is a shape that the more we do this, the better you'll have it memorized. This is just one period. So if we need to cut that in half, well, this coordinate that's at 0, 0 would still be there. But instead of pi over 2, 1, we'd be at half of pi over 2. So pi over 4, 1. And instead of pi, 0, we'd be at pi over 2, 0. And instead of 3 pi over 2, cut that in half. You're at 3 pi over 4. Where is 3 pi over 4? 3/4 is between 1/2 and 1. So basically all these points are now just 1 unit apart instead of 2 boxes, I mean. And then instead of 2 pi, cut that in half, you're at pi. So here's one period of the sine curve. So that is a skinnier version, a horizontal shrink of the red graph. Okay, let's continue graphing it. So just continue the pattern though. 1, 0, -1, 0. Here's a second period. So what is the length of the period, by the way? Well, the length of the period, this graph, sine graph, starts at 0 and then makes its full cycle at pi. So now the period is equal to pi. Let's continue it in the negative direction. So -1, 0, 1, 0, -1, 0, 1, 0. So that was just 2 periods. And it all connects back up to each other. How many periods of the graph can fit in this interval? So, okay, so we just sketched them in. So how many periods was that? Here's 1, 2, 3, 4. So the normal y equals sine x graph fit 2 periods. When we have a horizontal shrink by a factor of 1/2, now we get double that. We get 4 periods in because the graph is skinnier. All right, I'm going to get cut off for these last ones, so I'm going to save this for the second video when we move on to cosine.